Welcome to Truffle Security webinar on a recent vulnerability we disclosed to Google about Gemini. We've all visited probably thousands of times over a website that has a Google Maps widget embedded. If you click in, inspect element, so you're right clicking, in the browser you can see what looks like a secret. It's an API key. It starts with AIZA. It's in that box there. Historically, those Google API keys were not secrets. You're actually told to put them in front-end source code. This is the official Google Maps tutorial as of yesterday. Similar for Google Calendar. Again, you're told to put these keys directly in client-side code. Firebase, on their security checklist, says that these keys are not secrets. And it makes sense. These services don't allow users to access any sensitive user data or conduct sensitive operations. For that reason, when security researchers would report them on bug bounty programs, they would often get closed out as no impact, just informative. A few years ago, a couple researchers looked a little deeper into some edge cases with Google Maps API keys, like Osgar here in his Medium post, found some scenarios where there could be some minor impact, exhausting the monthly quota, maybe a slight overage on the bill, nothing super high impact or high severity though. That said, bug bounty programs started accepting a few of these edge cases that reported some impact beyond what was typical. And in this particular one, I wanted to highlight the top sentence here. It says, it, meaning the Google API key, lacked proper restrictions to prevent abuse of paid services. So what does that mean? Google has long provided users the ability to restrict their API keys. And this kind of makes sense. If you're putting something in client-side code, it makes sense to give users a couple restrictions there. And there's two different ones. One is an API restriction. So that says this key can only be used for whatever APIs you specify in Google Cloud. And then there's application restrictions saying only these apps can access and use this key. You can do that by website, which comes in the form of an HTTP refer header, IP address, Android or iOS apps. Google will be the first to say that these application restrictions are easily bypassable. iOS and Android apps, it literally says it in the documentation. I can attest to the websites one being super easy to bypass. And by default, keys aren't even restricted. When you go in and you create a new API key in the credentials section of GCP, the defaults, there's no restriction. And for those of us in security, we all know that most users are going to leave the default settings, just how it works. And that says something that this is how Google has created this logic. And so where are we right now? We've got these Google API keys. So they're used for Maps, YouTube, Google Calendar, Firebase, stuff like that. They're not secrets. They're more of an account identifier. They're allowed to be in public code. There are ways to restrict access, but some of them are bypassable. The default is not restricted, so it's kind of like, it's okay to put in client-side code. And then some researchers have dug a little deeper, found some ways to show like low impact. But again, that's mostly just exhausting quota, maybe a small financial concern. So all in all, these keys historically have been fine to put in client-side code. Now Gemini came into the picture a few years ago. This is totally different. These secrets are like passwords. So when I say, these keys are like secrets, which are treated like passwords. You are not to commit them into any public place. And they say that super explicitly. So you're probably saying, but wait, Joe, that's my name, by the way. Why are we talking about Gemini and Google Maps and we spent all this time on like all these like Google API keys? Well, surely they're different. They're not. That's the thing. Google's using the same API key format for two totally different purposes. The Google Maps scenario, which is meant to be public, and also Gemini, which is meant to be private and sensitive. And so now this is what can happen. In your GCP project, you can have one single API key that on the one hand, they tell you to put in plain public view for Google Maps, and they could also have access to Gemini, which they specifically say don't do. And that tension is where there's a cause for concern from a security perspective. So what did we report to Google? We reported a privilege escalation vulnerability. The idea here is if you enable the Gemini API, which is called the Generative Language API on a cloud project, existing keys that aren't properly restricted can silently inherit the ability to access Gemini. And so that means that we went from having only public identifiers that were safe to be in client-side code to now all of a sudden a subset or all of those keys in that project are now secrets too. There's no warning saying this. You're not getting an email saying this. It's not super well documented. You kind of have to know that this is the case. And that's the concern. And so there's two related problems here. There's this retroactive privilege escalation, which I was just explaining. And then the other side to it, in my opinion, is the default is insecure. It's creating unrestricted keys. And if you're creating an unrestricted key, which again is just the normal code flow, for the purposes of saying like creating a new Google Maps widget, but you have Gemini enabled in that account, your average developer is thinking, okay, I'm creating this widget. I'm going to put this key in client-side code because there's a tutorial telling me, but they might not realize that it's also actually a secret and it can access Gemini. So this, to be super crystal clear, here's the scenario. A few years ago, you created a website or you were involved in adding a Google Maps widget or YouTube, Firebase, whatever it is. So you put that credential in plain view public. Again, you were doing exactly what you were told to. Google said to do this. And then recently, you want to hop on the bandwagon of working with LLMs. Fantastic. You enable the generative language API. Now that key that was sitting in public, rightfully so, is a secret. And nobody tells you. And that's the frustrating part. And from an attacker's perspective, this is so trivial to exploit. You just scrape the internet. You could scrape GitHub repos. You could scrape just websites, whatever you want. There are thousands, probably millions of these AIZA Google API keys sitting in plain view. And then you just test to see if they can access Gemini. It's rather simple. So how big of a problem is this? When we report vulnerabilities at Truffle, we try to give the vendor that we're reporting to a sense of the scale of the problem. And in this particular project, what we decided to do was look at the November 2025 Common Crawl dataset. Common Crawl, for those of you unfamiliar, is a massive scrape of the public internet. There's just millions on millions of server responses containing HTML, JavaScript, and CSS. So we basically did a giant Control F to find as many AIZA strings that we could. We tested to see if they could access Gemini, and then we evaluated the context that they were in on the page. And we found 2,863 examples of live Google API keys that could access Gemini that were clearly placed in that website for some non-Gemini related purpose, whether it be YouTube, Maps, Calendar, whatever it may be. A lot of organizations were affected. The long tail are just these random websites, like that accounts for the majority, which makes sense. But there were large international banks, cybersecurity firms, and most interestingly, 2 different Google projects were impacted. And so here's a quick case study here on one of Google's own API keys. So when we got the list of results, we filtered and we saw that there were 2 Google subdomains. And so the first thing we did is we opened up the source code and we saw that there was nothing referencing Gemini around where that live Gemini or that Google API key was. But we wanted to double check that this had been there for a long time. And so we went to the Internet Archive, grabbed a snapshot of that code from before Gemini was even available, and that same Google API key was sitting there. And so what that confirmed to us is that even Google's own engineering teams followed their guidance. They placed a valid live Google API key in plain view, which again, you're supposed to do. And then somebody internally on that project activated the Gemini API, the generative language API, and they didn't remove it from public view. And now that is a secret. It's not just a public identifier. There's a lot of risks here. I'm going to dive a little deep here into the Files API. So sensitive data can be exfiltrated with one of these keys if it exists in your Gemini account. So it's not as simple as just using the API key and downloading any files that are uploaded. The files endpoint here is used to upload a file, and then you interact with that file via the model, whichever model you choose from Gemini. But you can't just like simply download it. But it's not that far off in terms of ease. So I'm going to do 3 steps. First, simulating what a victim would do. So this is uploading a super contrived example, by the way, uploading an AWS key in a file named secret.txt. It's a canary token. Don't worry, you don't have to test it. It's not, it might work, but it's not our token. You can see that it's uploaded successfully. The path is files/y7v00 something else. As the attacker now, so I pretend I grabbed that key from somewhere, I can easily list the files that are available. In this case, in that first row, it's that file we just uploaded. And then you just prompt Gemini to tell you what's in the content. So it's not really downloading it, but you're still extracting the content from these files, and it's rather trivial. You could do something similar with context caching, and I would imagine there are other situations I haven't considered in terms of accessing sensitive data, and more might come in the future. But at the moment, those are two endpoints to consider. There's also the financial consideration here. If you look at the bottom right, at the moment, the Gemini 3.1 Pro preview is about $18 per million tokens. I mean, depending on the quota that's available to that account, that could easily result in thousands of dollars of charges a day. There's an example similar to this. A student unknowingly uploaded and committed their Gemini API key to source code on GitHub. A threat actor grabbed it, or multiple, and started racking up a bill. Before they realized it, they had almost 60 grand in charges. Google was awesome. In this case, they waived the cost, but that's not guaranteed. And either way, this could cause a significant financial burden for an individual or business either way. There's also the scenario of denying service. So I'm not picking on Sirius here. I was just on their website. I don't know if they use Gemini, but I just wanted a screenshot of like a chat bot. So Sirius is using an AI-powered virtual assistant for one of their customer support channels. Imagine somebody uses all the quota available to that whatever some project has for Gemini, and now all of a sudden that organization's customer service channel is down. Again, I'm not picking on Sirius. I don't know if they use Google at all, but just to have a visual here, you can imagine now all of a sudden your customers are being rerouted somewhere else, and that could cause brand issues. Speaking of brand reputational harm and regulatory risk, this is an interesting article by Permiso. It's a little dark, but the idea is there are threat actors that run illegal, explicit, dark is just a good general term, chat services and similar, and they are stealing inference API keys for various services. It's not just Google, AWS Bedrock, all over the place. And that's what's powering the services. And if you are having sensitive, illegal, explicit content transiting over the wire to a project that you control in Google, there potentially could be a cause for reputational harm, or again, I'm not an expert on regulatory challenges, but this might force some disclosures. All right, remediation. What did we do? First thing we did is we reported it to GCP. If you've ever reported a security vulnerability, that first bullet shouldn't shock you. They brushed it off, and that happens. Like, no big deal. Like, it is not uncommon for somebody to come back to you and they're triaging a report saying, give me more justification as to why I should take this seriously. And so we provided some more data. They did take it seriously. They were super easy to work with. And the result was these 3 bullets. They already had a leaked credential pipeline in place. And that's to notify their customers when a credential is exposed. And so they added in all those API keys that we found. That was awesome. They also adjusted that logic to prevent those Google API keys that are found to be exposed on the public internet from accessing Gemini. So that immediately cuts off like almost the entire attack surface area. But what's even cooler is they addressed, well, they didn't address it yet. They announced to us, at least, their intention of fixing the root cause. And I think they articulated it very well. And that's that API keys that are enabled for a service that's fine to be in public view should not be accepted for a service that can disclose sensitive data, right? That's that tension between like the Google Maps public identifier and Gemini secret situation. They documented some of the next steps, some that they've already taken, some that they're going to take, like publicly online, which is awesome. And we're hopeful for what they'll do in the future. So if you use GCP, this is what you could do right now. My first recommendation is to check every project. So that's one of those organizing units in GCP to see if you have the generative language API enabled. If you do, don't panic. It's totally fine. Like, you should use it. It's a pretty awesome API. But if you do have it enabled, the second thing that you should do is audit your API keys. So look to see which keys can actually access that API. If it's an unrestricted key, you'll see that like caution warning icon. Those will be able to access it. And then you can also click in to see which keys have been scoped to access it. And then once you find those keys, just make sure they're not public. There's no cool screenshot here because this is a manual, tedious, annoying process. If you are at all concerned that maybe something was public, just rotate the key and put a new one in there that's scoped properly so that it can access Gemini if it needs to be public, or if it does need to access Gemini, just make sure it's not in public view. We recently added a truffle hog, that's our secret scanner, the ability to scan for Google API keys. The only results that we are showing as verified are Google API keys that can access Gemini, none of the other API services. That's all that I have for you guys. Hope you enjoyed this brief webinar. If you have any questions, you are always welcome to reach us at research@trufflesec.com. Thank you so much.